Welcome to this explainer. Okay, so today we're diving into an absolutely massive shift happening right now in the world of artificial intelligence. We're finally moving away from those simple chatbots that just sit there passively waiting for a prompt, and we're stepping fully into the era of autonomous systems that can actually do things for you. Okay, let's dive right into this. Here is our roadmap for the journey today. We're going to look at the evolution of AI. What happens when these AI brains finally get hands? Auto-GPT versus BabyAGI, real-world AI teams, and finally, we'll wrap up by looking at the dark side of all this. All right, starting off with Section 1, the evolution of AI. We're looking at the journey from basic systems to complex agentic networks. To really grasp where we are now in 2026, we kind of need to rewind and trace the timeline. In the 2010s, artificial intelligence was broadly just about systems mimicking human-level intelligence, like the facial recognition on your phone. Then 2022 brought the absolute explosion of generative AI, creating content using large language models. By 2023, we saw the rise of AI agents, individual models performing specific actions. But as you'll see, generative AI was just one stop on the road to full autonomy. Today, in 2026, we've arrived at agentic AI, which are these highly complex, multi-agent systems totally focused on achieving high-level goals. Let's zoom in on generative AI for a second. I want you to think of it strictly as a brain. If you ask a Gen AI model, hey, is gold a good investment right now? It searches its training data and generates an answer packed with historical facts and figures. But that's it. Its job ends exactly when that content is generated. It literally cannot go out into the real world and buy the gold for you. Which brings us nicely to Section 2, when brains get hands. We are moving from a reactive model to a proactive one. Now, what's really interesting about this slide is the sharp contrast here. Generative AI, it's highly reactive. It just sits and waits for you to ask a question, acting as the brain. Agentic AI, on the other hand, is completely proactive. It has the autonomy to act as the hands, actually using external tools to get things done without you needing to hold its hand the whole time. To bring this down to earth, let's use a software tech team analogy. A basic generative AI is like a solo coder that you just ask to write a single script. An AI agent? That's more like a specialized engineer, say a front-end developer, whose only job is to build a user interface. But agentic AI, that is the entire tech team, completely led by a project manager, all collaborating together to launch a full application. It's a goal-focused architecture, not just a task-focused one. Moving on to Section 3, Auto-GPT versus BabyAGI. Let's look under the hood at the 2026 framework landscape. So if you were watching this space back in 2023, you probably thought these two frameworks were direct competitors. But by 2026, they've completely diverged. You aren't really choosing between competitors anymore. You're choosing between a production platform and a teaching artifact. Auto-GPT is totally built for production now, featuring visual drag-and-drop builders, while BabyAGI remains this beautifully minimal reference architecture that's heavily favored for education and research. Let's break down BabyAGI first. The absolute brilliance of this framework is its elegant, minimal three-agent loop. First up, the execution agent completes a task using a large language model and saves the result. Second, the task creation agent looks at that result, looks at the main objective, and generates fresh subtasks. Finally, the prioritization agent reorganizes the to-do list so the most critical task is always up next. It's an incredibly elegant loop, which is exactly why it remains the most cited pattern in AI agent literature when people want conceptual clarity. But Auto-GPT, well, they went a completely different route, racking up an absolutely massive 183,000 plus stars on GitHub. Auto-GPT realized that a visual builder and a marketplace for prepackaged agent blocks were what people actually wanted. This massive shift toward becoming a platform layer caused a huge wave of community adoption, mainly because non-developers could suddenly build really useful workflows. Underneath all that massive popularity, Auto-GPT actually evolved its architecture into what's called a directed acyclic graph, or DAG system. They totally abandoned that early 2023 give it a goal and walk away framework. Honestly, that older method often just resulted in agents running in infinite loops and burning through people's API credits. Now, agents connect tools like web scrapers and Slack integrations through highly validated JSON blocks. So it trades the simple elegance of BabyAGI for some really massive, complex real-world capability. All right, Section 4, Real-World AI Teams. This is where we actually put the hands to work.
So when generative and agentic AI work together out in the wild, they follow a very specific four-step life cycle to automate workflows. First, the Gen AI brain creates an output or an insight. Second, the agentic AI analyzes that output and decides what needs to be done next. Third, the agent actually executes that task by hooking into external tools or APIs. And fourth, a continuous feedback loop evaluates the results so it can refine both the content and the execution over time.
Let's apply that life cycle to a real-world, highly complex goal. Say, investing 5 lakh rupees in gold, but only when the market conditions are actually favorable. A simple Gen AI cannot do this on its own. But an agentic system, it divides this into a multi-agent team. Agent 1 is your market monitor, constantly tracking pricing trends. Agent 2 is your financial advisor, calculating exactly how much of that 5 lakh to deploy at any given moment. And Agent 3 is your execution agent, which might just send you a quick email asking for confirmation before securely placing the buy order via a financial API. This brilliantly illustrates how a massive goal is broken down and handled by specialized agents working together. Now, zooming out to the enterprise space in 2026, while Auto-GPT and BabyAGI definitely laid the groundwork, most serious production teams have moved on to newer replacements. They're using LangGraph when they need incredibly fine-grained engineering control over agent states. They're using Crew AI, which perfectly handles that multi-agent, role-based orchestration we just talked about, or they're just using the official agent SDKs from Claude and OpenAI for really tight alignment directly with the foundation models. And now we have to make a pretty serious pivot into Section 5, the dark side. We're looking at autonomous agents in offensive security. Academic researchers have been taking a hard look at agentic AI in offensive security, and they've identified 3 major areas of what they call indeterminacy that make these systems fundamentally different from traditional deterministic hacking tools. First, these agents rely on non-deterministic policies, meaning their actions actively resist explanation, both before and after they happen. Second, because of the AI's internal agency and opaque supply chains, the actual impact of deploying them is completely open-ended. And third, perhaps most concerning, the skill floor required to launch an offensive attack has dropped sharply. You literally no longer need to be a highly trained practitioner to operate an offensive capability. And this brings up a truly chilling dilemma. To quote the researchers directly here, moral attribution becomes diffuse between users, tool makers, and third parties. See, when a traditional deterministic tool is used to breach a system, we know exactly who's responsible, right? The human operator. But when an autonomous agent is given a vague goal, starts writing its own code, interacts with third-party APIs on its own, and then unexpectedly attacks a system, the ethical blame becomes dangerously blurred. So what does this all mean? As we keep building these AI systems that act as both the brains and the hands, systems that can independently plan, execute, and adapt, we are left with a massive, unresolved dilemma. When an autonomous agent decides to attack, who do we hold responsible? It's a profound question that the industry is going to have to answer, and very soon. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and keep exploring the realities of AI.